Well, hey there, everyone. Welcome to the latest episode of the Union Podcast. I'm Scott King, and I am joined by Chris Kraus. Hey, Kraus, how are you?
Good.
Hey, glad everyone could join us. Today, we're going to talk about predictive analytics. Like, really, what is predictive analytics and how can it be used? So, I'm basically just going to read a description that I found online that I like. Predictive analytics is the process of using data to forecast future outcomes, right? Like we need to get better at doing things all the time. The process uses data analysis, machine learning, AI, and statistical models to find patterns that might predict future behavior. And we can all think of examples, sales examples, finance examples, like, what is going to come out of the data. And then, organizations can use this data to forecast trends, behaviors, and make better decisions. So, Chris, curious, how does predictive analytics intersect with AI and machine learning, and maybe what role does it play?
Well, if you remember, we talked about in an earlier podcast that really AI is the application of, in the biggest picture, machine learning is one of the categories, just like natural language processing, understanding natural language generation is a different area. But machine learning is literally math. It's like mathematical equations to calculate things. And so traditionally, like I have a degree in statistics, believe it or not. So quantitative business analysis. And so
I think I walked by that class.
Yeah. And so I use something called SAS software on the mainframe, and we would give it data and calculate, and then we'd plot it and look at it and see, do we put data in, we pull data out. So we had like linear regression and multivariate analysis. We had just a couple tools. Machine learning, we now have those tools are still valuable tools, and there's like anomaly detection is kind of, you can look for outliers in that. But the whole concept of neural networks, and basically we have more mathematical algorithms available than we had in the past. And one of the keys is, before you always said, okay, I need to calculate or have something specific. Now there's like unstructured learning where you can say, hey, ingest all this different information and start telling me things about it. So the machine learning models, we still have the traditional ones from statistics and analytics that we did, but we now have all these new ones that actually are powered by neural networks. And actually, we just have a bigger bag of things we can do. But they're all technically machine learning and based on mathematical algorithms.
Right. I mean, basically just to help us make better decisions. But
yeah,
you talked a little bit about neural networks, and I'm thinking about all of the data that we produce and that big enterprises produce, an enormous amount of data. So, like, how is the data prepared or maybe formulated for, to use the predictive analytics and to use the model? And like, what kind of data is typically used? Is it big data? Is it, structured data? Talk to us about how we would put that into a model.
So a lot of the things that we find with customers is they do have a specific goal in mind. They want to predict something like cash flow. They want to predict sales. Maybe it's B2C. So they have, Christmas is coming up, so they have historical stuff and that. So they kind of know the different information they want to deal with. And the goal is to calculate a number or predict a sales number percentage, or maybe like insurance companies have to predict possible loss based on a hurricane season. So they have inputs of how many hurricanes you think there will be. They have cost of living adjustments for how much, it costs to insure a house and rebuild and all those type of things. And so they spend a lot of time gathering those. But so there's lots and lots of data, but you're usually kind of fishing around in a specific area. So you kind of know your inputs. The neural networks aside, because that's, hey, just find something interesting. A lot of people know what are the contributing factors to sales. What are the contributing factors to a number inside the organization they're trying to predict. And when we think about automation, the nice thing is it kind of naturally points you to the data. So if we're thinking about, say, in a call center, can we calculate the value of this customer, the projected value of this customer? And we know how many devices they have, how many times they buy extra products. So we have a profile of them and we can predict future value of a customer. or maybe we want to predict, do we give them a discount because they're a high value or low value customer? All the data in the CRM, all the data in the sales systems themselves are what we would use to do that. So it's data we have. It's stuff we don't, we have access to. We just don't know how to process it.
Yeah, I'm curious. So I'm wrapped up in a process like that right now with T-Mobile. They keep texting me because I use a credit card to auto pay my phone
Yep.
bill, and they said, hey, to remain eligible for the auto pay discount, I forget, it's a percentage or maybe it's a hard dollar amount, $20, $25. I'm not really sure. They're like, you have to change from a credit card to a debit card because they're even looking at the processing fees. So
Yes.
somebody over there is, saw this and they're predicting how much money they're gonna, they're gonna save on processing fees.
Yeah.
I'm kind of curious to see that model, and that's like I have to go do that today, I think. All right, Chris, we talked about the data and, what kind of data is used, maybe where you get it, because you understand, the outcome that you want. So you kind of understand the data that you need. But the predictive model, someone creates those. Like,
Yes.
can you discuss how those are created, and do you need to be a data scientist to do this? Like, how easy or hard is this?
So that's what's really changed. Traditionally, you had math majors, you had statistics majors, and they did all this manually. And they figured out, applied them to specific algorithms and massaged the data. These days, machine learning, we have very good models for predictors, which is calculating a number. We have good things for categorization, like look at different pieces of data and categorize, should I give a discount, yes or no? So there's categorizations and predictors. There are lots of really good models out there, right? And they're multiple. So what we do in Krista, we say you really don't want a data scientist to understand the nuances of the 7 models. Give the data to Krista. We'll use machine learning to build machine learning, because we can actually take, say, 80% of the data, train a model, take 20%, test it, and try the first model, the second model, the third model. It's just CPU cycles at that point, and then tell you which one has the best score. There's different values like F1s and such, but we actually use machine learning to build machine learning models for you. So 30% of these things business need,
who would know
they're not
that?
super complicated.
You mentioned that twice, like machine learning to build machine learning. Like what's the real audience for that, right? Because I can't imagine that a lot of people would actually look for a solution like that.
So a lot of people don't know it's available. They think, they're very comfortable with pivot tables and things in Excel. So anybody who's actually, say, an Excel power user, they get their data, they do pivot tables, they're calculating things. They're the same people who can do this because we've lowered the technical bar. And when you build your pivot table, right, the data you want to look at and you're kind of looking for outcomes. That's the same data you want to give to a machine learning model. Now, if something is like statistically not important, it's not going to be highly contributed to the model. That's fine. You don't have to do that work. So literally, business people don't realize they have data in the context of their business process. You just want to put that into the model and have it do the work to figure out is it important or not.
Okay. All right. So if they know the data, they can use Excel, machine learning. I mean, basically, they're trying to improve a process. Like how does this help us automate processes, right? I mean, we're in the automation business, so we help people make decisions. But a lot of thinking is, I need this one data point at this one point in time, and then I do something else. Like people really don't understand that is automatable, right? So talk to us a little bit about that.
So every time you make a prediction about something, you're going to have, that's a decision point. And so instead of that being, oh, this is interesting, let me email someone or have a meeting, what are the steps in the process to do to actually automate the end-to-end outcome? So think of these as I'm actually automating the decision points that lead me down different paths for my automation to complete the tasks and then get to the outcome itself. So the cool thing is that machine learning applied to processes, it can actually be like highly confident and make the decision and the process automation continues, or maybe it informs someone and then they confirm the decision and moves on. But realize it should be, not everything should be a human decision. There's certain things like when you request vacation. Okay, say you're in a warehouse. The automation is going to look up to see, okay, how much vacation leave do you have? We can look into the forecasting engine and say, how many packages are we going to ship that week? You look in timesheets to see how many people are on shift. And then you would normally say, now let me give it to a manager because this is the information they're going to look at to make the decision. In this case, you can give that to a machine learning model and then it can make a decision, right? So the idea is you want to actually take the same data like a human would make a decision from, but have machine learning models ingest that and then make a decision for you. So it's your data is there, people just don't realize it.
Yeah, and they probably don't know that software could do that, right?
Right. And then
because
the action is
they've been hard coded to, I need to email somebody, I need to have a meeting, or if I need to be more comfortable with the decision, right? Like I don't want to make the decision. Let's have a committee, right? And then everything takes forever.
Right. And then like on the vacation leave, then who does the next step? Does the manager have to go put that in, say, Workday or the timesheet system, say they're off? Do they have to mark it on their calendars and all those things? Those are automatable steps. So once you've made the decision, the steps, if you grant the vacation, it's you then let them, mark it out, mark timesheets, let the HR system know they're going to take vacation on this date, all those things. All the steps behind it you want to automate versus that being more manual tasks.
Yeah, it's crazy. What about like a business case, right? Like higher level, somebody like in finance or operations may be looking at, like, can you share a case where the predictive analytics basically helped them collect all the data, improve the decision making process, and then invoked that next step, right? And from the decision, you have anything like that?
Yeah. So there's an interesting one in finance. So in finance, there's finance and accounting. Accounting is counting things up, and then financing a lot of times is predicting things like cash flow. So accounting can tell you we've sent out 100 invoices and the total value is $500,000 or $5 million, right? And ideally, the invoice has a due date. What are the terms? Net 10, net 30, things like that. But they don't know when it's actually going to be paid. So that's where finance is really interested. It's like, if we're going to calculate cash flow based on sending invoices out to be paid, how often does the customer pay the invoice early, on time, or late? And does that change based on the value of the invoice itself? So if you want to predict cash flow, it's not good enough to know the bills that went out. You need to predict the behavior of the people paying the invoices. Because you may find that, like, if the invoices say under $20,000, the vendors pay them within 2 days or 3 days. When the invoices are $20,000 to $100,000, they may pay them in 7 to 14 days, right? Mm-hmm. So there's some, by looking at the data, so in this case, you would want like 6 months of historical data. So you can look at invoices when they were shipped out and when they were paid and the value, and then ask for a predictor, a machine learning predictor, a calculated number, to come up with how many days it will be before this is paid. So that way, because some people will always pay early, some people pay late, some people vary that on the time, but you'd never be able to do that manually for 300 vendors, right? And all these invoices. So that's where machine learning, you give that, it'll ingest it, and it can actually predict for you, for this vendor, for this invoice price, when do you expect to be paid based on how they've done this in the past? So that's actually determining cash flow. So that means finance really can actually start predicting cash flow based on outstanding invoices. When will they be paid? What's the cash flow for next week, Friday, or 2 weeks out? So that's actually really interesting because people want to do that, but they usually don't have anything. Usually it's kind of a thumb in the air. We think, normally but
yeah, it's probably it's just someone that's been in accounting for a while, and they're like, oh yeah, that's my friend Jeff. He always pays it late, and sends me a cute little note every time that he does.
Yeah.
Right? It'll be
But
something like that.
yeah, how does a human remember that for 300 or 2,000 vendors, right?
Yeah.
Multinational companies with thousands of vendors, right? And consolidated accounting. So that's where machine learning models can actually predict that, because it's the volume. You'll exceed a human's ability to do that. If it's a mom and pop company and they have 5 vendors, that's one thing. When it's a multinational company and they have 2,000, 3,000 vendors, they won't be able to do that through guessing, right?
Yeah.
So applying that.
And then, especially with the turnover in any organization, right? I mean, just having kind of a repeatable process and using the analytics, on top of that would benefit everybody, right? So when we talked about what is the analytics and the machine learning models and machine learning to build machine learning and, formulating the data and then doing the next step. What's the next step after that? So what's the future of predictive analytics and like where do you see it headed?
So I definitely see it. Now we've got a number, we've made a decision. People will realize, okay, we've solved the decision point faster. This is no longer a decision by committee or having someone do a research project. Now what do I do? Okay, what are the next steps in the process to automate? Is like, do we actually have to take action in this? Do we update? And like, if I told, say in finance, we said, okay, we predict that in the next 2 weeks, we'll get $1 million of invoices paid. And then 4 weeks, we'll have $7 million of invoices. Well, someone can make a decision to say, okay, any of those we think will be paid in the middle, let's send a promotion to them to say, we'll give you an extra 1% off if you pay early, because the cash value in our hand is more valuable to us to get it by the end of the quarter, right? So people will think about, I now have better information, I have predictions. Now, can I do something with it to make my business better? Can I apply some automation to say, nudge people to pay or entice them to do things differently, right? So they will rethink about how do you actually run your business better versus just the status quo. And the key is you want to automate some actions after you've made those predictions.
Yeah, I like that. I mean, it's got to be better, right? So everyone's looking into AI and they're looking into how to make better decisions with math, because we just have a ton of data, so we might as well use it effectively. So I like that. Yeah. So thanks, Chris, and thanks everyone for listening about predictive analytics. Hope you learned something. Be sure and subscribe to the Union on YouTube or any of your favorite podcast players. And until next time.